So that brings us to comparison. Unchecked and low means turn on the outputs when the input is lower than the set point, typical for heating. So I'm going to put a check in the box for comparison so that it says high, which means the outputs will turn on when the return air temp is higher than the set points, because high return air temp means turn on cooling. Timer units is next. Unchecked means seconds, checked means minutes, and there are various timing parameters. There's delayed start and stop times that apply to all stages, including all stages off to first stage on. And there's also minimum on and off periods for each stage. And so the number that you can enter in those timing fields is anywhere between 0 and 255. So if you need more than 4 minutes, then you're probably going to need timer units equal to minutes. So in our case, seconds is fine. To the right of the input handle name is a units setting, which the controller doesn't really care about, but it's good for somebody looking at the programming. So in this case, it says, what are the units for the input values? And so that's hundredths of a degree Fahrenheit. So if I click on the units field, there's 0.01 degrees F. That little circle with a slash through it's meant to be a degrees sign. Delayed start and stop time is just a delay between stages turning on. So I'll just put in some small numbers just so we can see that they work. So delayed start time, I'll put in 15 seconds. Delayed stop time, I'll put in 20 seconds. And then starting from stage 1, I need to enable however many stages are needed. So in this case, for my cooling sequence, remembering that I actually have 3 stages, 1 for economizer, and then 2 stages of cooling beyond that. So I need a total of 3 stages, which means enable by putting checks in the boxes for stages 1, 2, and 3. And notice when you enable the stages in the upper right corner, it will show you information about that output. So that's part of that script running in the background that tries to show you only the settings that are relevant to the current program to kind of help you focus a little bit better. Since we're using the reset handle, here's the reset input value. That's the number being read from the reset handle. And so the way the stage set points work with the reset handle is the active set point is the reset input value plus the stage set point. So you can think of that as sequence object, active stage 1 set point equals reset input value plus stage 1 set point. And for stage 2 and stage 3, it's the reset input value plus the stage 2 set point. For stage 3, it's the reset input value plus the stage 3 set point. So I want the economizer to be able to start opening before mechanical cooling begins. So if my base set point is for mechanical cooling, I can actually put in a negative set point for stage 1. So if I put in like negative 50, then above 73.5, the economizer will start to open if the outside conditions are good, and that hopefully will cool down the space before it gets to 74, at which point mechanical cooling will turn on. So the stage 2 set point for mechanical cooling stage 1 will be 0. I want that one to turn on at 74 degrees. And the stage 3 set point, I'm going to put in 200. So that stage 2 cooling turns on at above 76. This hysteresis is the same, it's that same deadband type setting to tell us when to turn off. So my economizer will become enabled above 73.5. If I put in 50 for the hysteresis, it'll turn off and disable the economizer if the return air temp drops below 73. And the hysteresis should always be a positive number, should never be negative. The stage 2 set point turns on above 74. If I set the hysteresis to 100 for 1.00 degrees, then if the return air temp drops 1 degree lower to 73, then we'll turn off cooling 1. And for stage 3, I'll also put in a hysteresis of 100 so that it turns on above 76 and turns off below 75. There are min on and off settings in the sequence. I usually don't use them in the sequence object. If I do need min on off, I usually just do them directly at the output. You can do them in either or both locations. But in this case, I'll just leave them at 0. And so I'll click the save icon to save my program on my computer and save the graphical programming into the controller. If I go back to the graphical representation of my program, right now the interlock value is 0. And so the sequence won't run at all as long as the interlock is not enabled. So one of the benefits of graphical programming is that it kind of helps you easily follow the program flow. And so I can see the interlock value is 0. Why is that? Well, it's because this logic is off. I'm just kind of straightening out some of my lines here to make it easier to read. Why is this logic off? Well, it will turn on if the A value is 0 and the B value is non-zero. So what's holding it off? It's that the A value is not equal to 0. Why is that? It's linked to that fault status parameter. So the sequences are currently being locked out, not because I don't have enough duct static pressure, but because my return air temp is in fault. So if I go into the properties of my return air temp, I can see that it's in fault. And so what we normally do in the in-person training class, again, we'd connect a potentiometer that would simulate temperature. In this case, we're going to override the input. However, the input object won't check the fault status to see if a change is needed when overridden. So what I'm going to do, since I don't have a sensor connected and I just want to override, I'm going to go to the Alarms and Limits tab, and I'll just temporarily deselect low limit enable so that it will never go into a low limit fault because that's the fault that was active. And then if I was using this program for a controller on site, then I would need to remember to set low limit enable back to yes once I wired everything up. So you should have no faults now once you deselect low limit enable, set it to no. And so now on the Input-AI tab, I can use the Input Action button to override the input. Then once I confirm that input OR status is yes, then even though present value is purple, I can click on it. So I'll put in 7450 for 74.5 degrees. That value should stick as long as input OR status is yes. And if I go to the graphical programming, I'll see that the interlock handle is now 1, which means the cooling sequence can proceed. And if I go to the properties of my cooling sequence, then I can see output 1 turned on, and then after a 15-second delay, then output 2 will turn on. So once this delay counts down to 0, output 2 turns on, and that will cause the cooling 1 relay to turn on. Notice here I can also see the input value that shows me the number that is seen by the input handle. So that's my return air temperature. You don't actually see the calculated, what I've termed as the active set points. So the controller kind of has these, kind of behind the scenes. You won't actually see the results of this calculation. You'll just have to know to add reset input value to the stage set point to know what its active value is. So now, before output 3 from the sequence would turn on, the return air temp would need to go above 74 plus 2, or 76 degrees. So if I go to the return air temp input, confirm that input OR status is still yes. Click on the present value and type in 7650. Did I make a note about that binary? In fact, yeah. Then if I go back to the cooling sequence, then that delayed start time of 15 seconds counts down, and output 3 of the sequence turns on. So if I look at the graphical programming of my cooling heating group, I'll see that both the cooling 1 output and cooling 2 outputs are on. Is your sequence behaving similarly? No comments. I guess that means it's okay. I don't see anything in chat either.
No, I don't see. I think I still have on for all my cooling.
Okay, let me take a look. Jason, I'll make you the presenter. Go ahead and share your screen. Yeah, so that's right. All of your outputs are on. I see that in the upper right corner. If you go back to the graphical programming, we can make sure that the relays themselves are on. So click on the left side, the name of your group, cooling and heating. Yeah, so that looks right. Is there something you see there that doesn't look right to you? I think it's okay. So you can also, for the lower, yeah, it looks good to me. So what I would do though is for the lower heating sequence, I would connect the sequence output 1 to heating 1 and the sequence output 2 to heating 2, just so that when we program the heating sequence, those relays will turn on appropriately. Okay, I'll make myself the presenter again and share. And so if the interlock does ever drop out while the outputs are on, there's not a graceful shutdown. We don't honor the delayed, stop times. It just shuts everything down. So if you did need to have a more graceful shutdown, there are like delayed stop timers you could use external to the sequence that you could consider using. But I'll just show you that they do all sweep off. So there's a few different ways I could get the interlock handle to drop out. One we saw would be to have a return air temp fault. Another would be if the duct static pressure dropped below half an inch. So I'll just use the return air temp by just putting a check in the box for low limit enable, and we'll see that the outputs just immediately turn off. So if I go to the return air temp properties, alarms and limits tab, and set low limit enable back to yes, then it goes into fault. And if I go back and look at my cooling and heating group, oh, you know what? I said when it's overridden, it doesn't check for faults, didn't I? So I'll just do something different. Then I'll go to my duct static input and just change the present value, since mine is still overridden. If I change it to be less than 30, I'll just put in 0. Then the controller should think the fan dropped out. So the B handle is no longer non-zero, so that logic turns off. The interlock drops out, all the outputs immediately turn off. Once the interlock handle is reestablished, meaning it turns on again, then it will gracefully ramp up, honoring the delayed start time. So we'll just confirm that. With duct static properties, present value, I'll just go back to 7650. Oops, that's the input. Duct static properties back to 160. And now if I look at my cooling sequence properties, then there's the delayed start for output 1 to turn on, then output 2 turns on after its delayed start counts down. And notice the min on off will count from 1 and 0. There is a minimum value of 1 for the min on off. So if you're in minutes, that's more kind of substantial, more significant than when it's a 1 second, because when it turns on, it will stay on for at least a minute. So then they all gracefully staged up. And one thing I didn't include in this program, which I could, I'm not saying, there's nothing in here that prevents heating and cooling from running at the same time. I think from a practical sense, since I have a 2-degree differential between the cooling and the heating set points, I don't think the return air temp would really drop by 2 degrees very quickly. So it should naturally prevent cooling and heating from running at the same time. But there are ways you could build on the program. You could add to the interlock case for heating that says don't let the heating run if cooling 1 is on, and likewise you could say don't let the cooling run if heating 1 is on. So there's ways you can add more detail to the programming, but this being sort of an introduction, I limit it to keep it slightly simple. So that is the cooling sequence. And so what I'm going to have you do for the heating sequence is try to program it a little independently. I'll just give you a few minutes. If you don't get it all, that's fine. But I think you'll kind of think about the programming a little bit differently when you're trying to make it work on your own, as opposed to just clicking where I tell you to and typing what I tell you to. So for the heating sequence, what I want to do is heating 1 on when RAT less than 72 and off when RAT greater than 73, and heating 2 on when RAT less than 70 and off when RAT greater than 71. I'll go ahead and program mine, and then you can check yours and let me know if you have any questions. So I'll go to my heating sequence properties. And it looks like Colin dropped out from the meeting. Jason, is he having a computer problem? Did he have to leave, or what happened there?
Yeah, it's just a Wi-Fi thing. We kind of just work together on the same computer through this.
Okay, all right. So we'll call this one heating SEQ. Am I using the reset handle? Yes, I am. Am I using the interlock handle? Yes, I am. I'm not using the cascade handle, so both of those are set to no. In the heating case, comparison should be low so that the outputs turn on when the input is lower than the set point. Units for the input handle can be set to 0.01 degrees F. Delayed start and stop time can be 15 as the start, 20 as the stop, just like before. I only need 2 stages since there's no equivalent of economizer for heating, so I'll enable stages 1 and 2. And then the stage 1 set point is 0 because I want stage 1 to turn on below 72. So that would be 72 plus 0. And then for stage 2, I put in minus 200 because I want stage 2 to turn on at 72 plus negative 2, or 72 minus 200 to be 70 degrees. The hysteresis would be 100 for each stage. That means stage 1 on below 72, off above 73. Stage 2 on below 70, off above 71. So I can test that by going to my return air temp properties and setting the temperature down to say 7150. Then if I go to my heating sequence, after the delayed start time, output number 1 should turn on. Probably a good time to hit the Save Device Archive icon while it's getting ready to run. There's output number 1. And then I will lower my return air temp even further to 6950. 6950. And then the heating sequence, oh, there you go, Colin's back. 6950, and after the delayed start period, output 2 turns on. If I go to my graphical programming group, I can see that, yes, in fact, both those heating stages are on. might be good to see that the interlock handle is working correctly. So I'll take my duct static properties, change the overridden present value down to 0 again, go back to the graphical view, interlock handle dropped out, heating output's turned off. So I think that's working correctly. I can go and put my duct static back at 145. It'll ramp up. And does anybody have questions about how their heating sequence is working?
No, if you could, can you just explain that interlock for me real quick?
Yeah, so the interlock handle is used to say, don't allow the sequence to proceed if the interlock handle is 0, because I don't want the heating and the cooling to run if I don't have enough duct static pressure. Right? So if the duct static pressure went down to 0, as an example, I would not want my heating and cooling to run. And as part of this interlock handle, I'm also looking at the return air temp value to see if there's any signs of a wiring problem, either an open connection or a shorted connection, because if it's open and the value tends to be very low, and that might cause the heating to run indefinitely. And if it's shorted, that would tend to cause the temperature to read very high, which would normally cause the cooling to run indefinitely. So I'm kind of protecting against that, because you can't heat or cool, in this case, if the return air temp is not reliable, and I shouldn't heat or cool if the fan's not running, because that might damage the equipment. Does that make sense?
Can you go over the set point thing for me? I'm actually kind of confused on where we put our set points in, where you put 0 and -200.
Yeah, sure. So
I would think that you want your first set point, your first temperature, and then your other one, like you said, you wanted it 73 and 71. They don't put those numbers in on the set points.
So here in this text document, I said I want heating 1 to turn on when the return air temp gets below 72 and off when it goes up by a degree to 73. If the return air temp continues to drop below 70, then I want to turn on stage 2 and have it turn off above 71. And so the way I do that in the sequence object, since I'm using the reset handle, 72 plus 0 gets me the 72 degree set point for stage 1. 72 plus -200 gets me the 70 degrees for the stage 2 set point. And then they both turn on at 1 degree above.
Right. Yeah. I'm used to just putting a regular set point in place, not having to do the mathematics to make it happen. Okay.
Yeah, if you weren't using the reset handle, you could have put just 7200 in here and 7000 in here. The reason I don't like to do that with multiple stages is then you have to give the end user, you don't have to, but you typically give the end user both set points if they were adjusting them. And if they don't keep them sort of, aligned together, then that could get you to some odd operation. So I like to give the end user just one base set point. Yep.
Oh, that makes sense. I just didn't understand how you got your 0 and -200 and how you're doing it. I didn't catch that in the cooling sequence.
Yeah, so it's similar to this in that the active set point is the reset input value plus the individual stage set point. And so the negative is kind of the weirdest thing on the heating set point, because you might not expect that to have to be a negative number. So going back to the programming here, I could try to straighten out some lines if I want. You could drag everything across if you want to move things over. Notice you do have horizontal and vertical scroll bars, so you do have more programming space than is visible on the screen at any given time. Again, you could move if you want to keep your lines straight, you can move some things around. This is pretty easy to read, from my standpoint, but I could put in some small notes or large notes. I usually at least like to put in a large note, which is the name of the function group. So I'll do a right click large note and just type cooling and heating. Put that up here. You can see the name of the group here above the Functions tab, but otherwise, to me, it's not very obvious which one you're looking at when you have multiple groups. It's not obvious which one you're actually looking at on the right, but if you have that large node, I think it makes it more obvious. So I'll hit the save icon. One other thing I like to do periodically is use save as to save a second copy in case something happens to my first copy. I don't do that quite as often, but just to give an example, I'll click the middle disk icon for save as. And then if you've already created a backup folder, I tend to just save it in there. If you want to create a folder, you can click the little new folder icon that has a little star on it. I'll just go into backup. You could give it a more descriptive name. I tend to just leave the default name. A2 means it's a programmable controller. 9540 is the model number. 9505 is the ASI